Hey everybody, and welcome to Pratt Laboratories. I, Mr. Pratt, will be your scientist for today. By the end of this video, you should be able to answer the question, is air there? Is air a substance, yes or no? I mean, I look around, I don't see it, I don't really smell it. So we're going to prove for you today that air is a substance. Let's begin. Take a look around me. We have a few things going on here. I'm going to get this started up. On my stove here, I've got just an empty pot right now. We're going to turn that on to high, get it warming up. I'm going to put into that Arrowhead spring water. It's unopened. I'm just going to twist, open that up, and I'm going to dump it into my pot here. We'll come back to that later. While that warms up, let me show you what else we have going on. Just a regular old garbage can here. Nothing to it. I have a thermometer. Technically a meat thermometer, but we're going to use it for air because, well, that's what's available. What are these weird things, Mr. Pratt? You'll find out once we get there. I have just a regular old funnel. We'll put that there by the water bottle because that's what we're going to use it. A cup. Safety first, right? Hot pads, a couple of paper towels, a pinwheel, and a fan. Okay, so let's begin with the thermometer. Okay, this one, we're going to have to go on a little bit of a field trip here because what I want to do is show you that the air has temperature. So we're going to take this thermometer and I'm just going to turn it on. And I'm going to hold it up over my head and then we're going to count down from 10, 9,
8, 7, 6, 5, 4, 3,
2, 1. And then I'm going to take a look at that. And my thermometer is going to tell me that the air temperature here in the room is 68.3 degrees. So 68 degrees right now here in the room. Let's take a field trip. Let's go outside. Okay, we're here. First stop of our field trip. Got my thermometer in hand here. Let's see what the temperature outside is. Count with me. 10, 9,
8, 7, 6, 5, 4, 3,
2, 1, 0. Let's see what it registers. Okay, 57, 58.1, 58.2, 58.3. Okay, so you can see it's going to vary a little bit depending on what the breeze is doing, what it's bringing in. But you can see that it definitely has a temperature out here. How about we make one more stop on our field trip? Oh, a little dizzy there. We're at our third and final stop on our field trip, okay? So we've got the thermometer here. Now let's count. 10, 9,
8, 7, 6, 5, 4, 3,
2, 1. Here we go. Now take a look at it. Okay, 67.5, 4, 3, 67.3, 67.2, 67.1. Okay, so clearly again, we have a temperature here in the lobby of the school. Welcome to our third stop. How about we head back to the classroom? All right, now that we're back, we have our three temperatures. All of this has proven to us that it doesn't matter where we are, air has temperature. That is our first line of evidence for why I believe air is a substance, why air is there. Air has temperature. Let's move on to our next one here. Let's come over here to the fan. Now, we all know if I flip this on, that fan's going to start spinning. I could talk into it. Okay, so the fan is spinning because there's electricity. The electricity is powering the motor causes it to spin. I have a pinwheel here. I could cause the pinwheel to spin. This is my finger causing it to spin. Now, I'm either a Jedi or there's something else going on, but when I just hold the very end of the stick here and I stick it in front of the fan, oh, use the force. The pinwheel is spinning. Take it away. It stops. Put it in front. it spins. Stop it. It still spins. The force is strong in this one. So what's going on here? Okay, the fan gets its electricity from the wall, causing that little motor to spin. But then as that fan blade is spinning, it's pushing the air. This takes us to our second line of evidence. Air moves. We can see that being demonstrated by the fact that the pinwheel is not plugged into the wall, but the pinwheel is still spinning because the fan is moving the air toward the pinwheel, causing the pinwheel to move. So there we have our first two lines of evidence. Number one, air has temperature. Number two, air moves. Let's see, our water still heating up there. So we're going to take a break with that and come over to here. I've got a bunch of paper towels here, perfectly dry, okay? I'm going to crumple those up. I'm going to stick them into the bottom of my glass here. Now I'm going to cram them way down in. I want them down at the very bottom of the glass. Now if I take this glass and I stick it upside down, I have here in front of me a tub of water. Now if you'll notice, that tub of water is taller than my glass. And I've got the water filled up to the point that when I stick that in there, this cup is going to be completely submerged. Now remember, when I stuck these paper towels into this cup, they were perfectly dry. You want to feel? Just kidding. You can't feel. But I stick it in there, and it goes all the way in. That paper towel is completely submerged in the water. Completely. Water comes up all the way to the bottom of the cup. And I'm sitting there, and I look, and I was like, oh, yep. I see that paper towel underneath the water. Now when I pick it up, I stick my dry hand in and I pull that out. These paper towels are still perfectly dry. Perfectly dry. Feel. Okay? Perfectly dry paper towels. Now, I'm going to teach you something here. While this continues to boil, I'm going to teach you something about the law of thermal expansion. That's what these puppies are here for. Now to help me teach this lesson, we're just going to scooch this out of the way. To help me teach this lesson, I brought a friend. Oh, lots of friends actually. This is just simply a bag of ice. Now I know you students. Here, there's some for you, and there's some for you, and there's some for you. Open your mouth, come on. I'll get it in there. I'll get it in there. Catch it! Okay, so it's just a bag of ice. We are going to, first off with this ball and ring, I just want to show you that with fairly minimal effort, I can get the ball through the ring. Okay, fairly minimally. Now, law of thermal expansion. Remember that prefix thermometer, thermos holds in heat. That prefix therm just means heat. So thermal expansion meaning things get bigger. So that means as we heat something up, it expands. Think about like a hot air balloon. They thrust that fire underneath that, and the balloon gets bigger. There's no more air going into that balloon. It's just pumping it up because the air is getting bigger as it gets hotter. So, if I take my ring, and I stick it into there, and I take my ball, and I stick it into there, and we just wait for just 1 minute. You want to come on up. Just kidding, it's a video. I wish you could. Some of you did. We did this in class already, and it was great fun. But I stick the ball into the boiling water, I stick the ring into the ice. Suddenly, we bring the biggest and baddest kid up in class, which at this point has to be me, Mr. Pratt. It no longer fits. Thermal expansion. I put the ring into the ice so it cooled off. I put the ball into the heat so it expanded. The ring is contracting, the ball is getting bigger. So when A plus B used to equal C, it no longer fits through. However, if I flip that, now the fun of this was, when I brought up our little friend. And I said, okay, now we're gonna have her try. You know, you got big buff football player, Muh. I can fit this ring through, and he couldn't. Then I was like, all right, come on up, come on up. And she was able to grab them, and with ease, like no effort at all, it fits through. It's because I flipped them. I put the ball into the ice, so the ball is contracting, and the ring into the hot, so the ring got bigger. The law of thermal expansion says that things get bigger when they're heated up. Now, why does this matter, you're asking me? Why does this matter, Mr. Pratt? Let me show you, okay? Push the ice off to the side. We're gonna bring this in front. I'm gonna start with my bottle here. You remember that spring water that we poured in there? Safety first. Let's put on my heating pads. Boom. Funnel. It's going to help us pour. We're going to fill this bottle a little less than half full of that boiling hot water. Okay, a little less than half full. And then I'm going to seal it. Now what that sealing has done, all of that air that's trapped in there with the water is being heated up by the hot water. So we're going to now turn that off because we're done with it. We're going to take some ice here and kind of put it on the bottom so that there's some underneath us. And then I'm just going to take that bottle, stick it in there, and then we're going to cover it with ice. Ooh, we're losing ice. Oh well. I have more than I need. We're just going to dump that full of ice. This is what happens when you film without cuts. Y'all are welcome. Grade A TV here. Just get this back into the bag so we don't get too much water all over my classroom. Now I can show you that bottle's completely covered. So while that sits and does its thing, let's just come back to our experiment here because I never quite clarified what was going on. As we stuck the cup in, the paper towels were in the top of the cup. And at that point, the paper towel was completely underwater. But as I put that on, what would be in between the water, which was down here, and the paper towel, which was up there? Okay, we had that gap there that as long as you go in flat, like so, inside that gets trapped the air. You can see, I don't know if it's going to translate, but if I go bloop, I get big bubbles. Bloop, bubble. Bloop, I'm letting out the air that was in there. So in between the paper towel and the water was air keeping the paper towel from getting wet. So that proved our third point. Air takes up space. It took up the space between the paper towel and the water, keeping the paper towel dry. Okay, so we had 3 points that we've proven now. We've got a fourth one on the way here. Number 1, air has temperature. Number 2, air moves. Hopefully that wasn't too much of a distraction. I meant to turn it off sooner. So number 1, air has temperature. Number 2, air moves. Number 3, air takes up space. Now in between all that, I taught you the law of thermal expansion, things getting bigger as they get heated. And then I put hot water into that bottle and trapped it. So that hot water is pushing out on the edges of the bottle. Now the plastic is hard enough that it can't expand it. It's not like a balloon that it can blow it up, but it's pushing out against the edges. the air on the outside is pushing in on it. So once I've cooled that air off and it's no longer pushing out as hard, we have a different result. I'm going to come back in here now, and I'm going to try and do this in such a way that you can really see that I am not crushing this bottle at all, but when I pull it out, squish, it's been flattened, okay? This bottle is squished. This proves for us our fourth point. Air has pressure. So the hot air was pushing out on the bottle, the cooler air, the 68-degree air around me, was pushing in. But as that air on the inside cooled off, it's not pushing out as hard. The air on the outside is able to squash it, causing us this. So, point 1, air has temperature, 68.4 degrees. Example 2, air moves. We turn on the fan. It causes the pinwheel to move with the force. Point number 3, air takes up space. And point number 4, air has pressure. It's with these 4 ideas that I can say with certainty that air is a substance. In response to our big question, is air there? Our answer is yes. Hope you learned something. Have fun with your writing assignment.